going around like Gary after this.
Gary.
Right?
Is he in town?
I'm meeting him at his house. So he told me to tell you hi and everything. Oh, I think he's been in Colorado. I don't think he has service or anything. Yeah, he told me to make sure to tell you, say hi.
Yeah.
Okay, good morning, guys.
Morning.
That's good. All right, thank you guys all for coming. My name is Chad Kirby, and I'm the electrical instructor for the electrical design program here at W. Been at W for 13 years now, so I got a lot of students who graduated. They're doing good here all over. So, the electrical design program, guys, is a 2-year program. Graduate electrical designers and estimators and project managers for the industry, the construction industry and engineering industry in the state of Minnesota. And what you're witnessing today is a 25,000 square foot industrial building with manufacturing floor, complete design, power, lighting, and low voltage with power system analysis and load calculation and a bunch of other things. So, and in front of you guys, we have the agenda here. We only have 4 teams, 4 students this time. This is the lowest in years that we have. The good news is next year we already have 7, and that's that we will have at least 10 to 12 students next coming year. So it's coming. You have the agenda in front of you guys, and also the second page has the teams. The teams this time is only team 1 students, and they're going to be presenting certain aspects of the project. The second page is actually the front and back, and I will remind you guys that there's a sheet at the end. I would like you to take a second here to evaluate the student. 1 through 10, how they presented it. So, and then I would like you guys to give me that sheet at the end, the last sheet. This is we'll have an input in the grade. I do have a sheet in the front of me here. I would like you guys also to write your name and the company that you're in. So we start right here, housekeeping stuff. And before we start, I would like to thank Receptacle for adopting this project. I don't know if you guys know, for the last, my God, 16 years, guys, or more than I've been done with it. This project has been administered and adopted literally adopted by Receptacle with tons of presentation that they do here for us and field trips. So, without further ado, I would like to invite my friend Guy here to say a few things to the graduates in the industry.
Thanks, Dan. It's been fun to be a part of Dunwoody, and I don't know exactly 17 years ago. We decided to help with this project, and the semester was on industrial, and those who know the shop really are. We're not really designing industrial facilities or oil facilities or big power plants, but we were involved with designs for, at the time, SciMed Medical, which is now bought by Boston Scientific. Back then, we were doing the SciMed projects in Maple Grove, and SciMed would manufacture stents and other medical devices. So it is a manufacturing, it is an industrial, it's sort of a light industrial. So when the need came up and the opportunity came up, we thought, hey, we could sort of model this after the work that we've been doing for SciMed, Boston Scientific. So we did get involved, and it's been fun. As part of the project, Rashad, myself, and with help with Phil, and Nick, we're the owner, we're the architect, we're the mechanical engineer, so we create our scope narrative, we create a background as the architect, we create our motor list, we create our owner equipment list, and then, you know, the students have to come up with an electrical design for the project. And throughout the course, we try to give some other industry resources to the students, so we help line up tours. I see Greg and George from Allianz, so we bring them tours through Allianz facility. We've been doing this almost from the beginning, so thank you to you guys for willing to bring the students through and walk through your facility. Allianz is a big office facility here out at 394. You know, it's not industrial, but we put in an office component. We also put in a data center component in our project, and so we get to go through some office primarily, also looking at their data center, and then looking at the main mechanical spaces, which in that large facility are pretty impressive for the students to see. But in addition to the tours of Allianz, we do bring them to Boston Scientific because this is sort of the core of where it all started. So they're in the rooms, the manufacturing clean rooms. So I think it's helpful to get a perspective from this point of view of what this project is all about. So a little background, and then I'm sort of highlighting these tours because, you know, with the Allianz folks here, and hopefully over time some of the other people that have been involved with the support of this program. I think it's done with success. So, internally, we talk about is it time to change it? Maybe we've tweaked it along the way. We've gone from 20 watts a square foot in the data center to what we're at 150 watts a square foot. So we keep making the data center a little bit more complex. But you know, at the end, we say, well, we've got a pretty good system in play. We're all volunteers, and it's new to the students. So we'll try to make sure it doesn't get stale. As long as we keep it fresh, we'll probably see this project for a while. Right?
I just want to bring to your attention, guys, the blueprints are on the wall right here. You can see them. And one of the presentation will walk you right through the blueprints as well. So there's one project here, one in the back here, one right in here. We also have all the aspects of the project documented, and we call it the portfolio project. So all the calculations that they do, they document it right here. From the coolant calculation into the energy coolant, the arc flash, everything is documented. That's the project. So without further ado, we do have a small group this year. It's only more presentations, and I'm going to introduce my friend Matt Foreman, and Matt will MC the presentation moving forward. So that's
Thanks, Chad. Thanks everyone for coming out. Had a great turnout. Like you said, we spent the last 10.5 weeks designing a mixed commercial industrial facility. 25% future growth. We also had this semester we Chad Cooley and helping us with the design growth. In the past, we classes divided up into two, but this semester there's only 4 of us, so it's on the project. I believe that this helps us much more efficient, or become much more efficient, and also affects our future here, like all the software that we use. Together, that's 2013. Power tools for Windows, contract, video lighting software, Microsoft Tablet and Excel, and some of the PowerSuite. Of course, we could not have done all this without help, so I'd like to thank, first of all, my fellow classmates, Chad for being a great instructor, Hecting Guy from Rashad for coming in and helping, and anyone that came and spoke, all the places that likes coming through like I am. And so without further ado, I'd like to start out today. Derek will be talking about the design drawings, the project schedule, and
How you guys doing? Thank you for coming. So I appreciate it. Like you said, my name is Derek Wickham. What I'm going to be taking you through here on our industrial projects is going to be overview of our sheet set, the power riser, power system operation, our equipment product sheets are load calculation and the project schedule. And part of that overview sheet is also going to be kind of the scope of our project exactly what it is. So, just to start, on our title sheet for our project, the scope of our project included an electrical design for a complete electrical design for electrical distribution, emergency power, lighting, normal power, and communications low voltage. So, our building is roughly a 22,000 square foot medical manufacturing plant. So I'm just going to go quickly kind of through the slides. They'll get a little bit more in depth with the other students. They're going to take you through these a little bit more in detail. So second set would be the power risers that we had. Third set here is just some of the low voltage programs or risers that we had for those. And then these would be used from the larger sheet sets. So site powers, lighting plans, and breaking down into the power plans for these. Now this one is our first floor, second floor, and then here's where we start going into low voltage systems. So you'll be able to see some of this more later. Second floor low voltage systems for those. And then also into lighting protection, which we also go in a little bit more detail for you too. So we also did do our project schedules for these, which we developed through Revit. So for those for mechanical and owner schedules for the equipment for that, our lighting schedules, like I said, our owner equipment schedules also, and then the mechanical equipment schedules. And then the details that we went through that for full base, generator bases, and then lighting protection that we also have for these two. So, all right, just kind of an overview of our sheets. Our title sheets included information that's pertinent to it. So you'll see that sheets like this are going to include for us, just what sheets are included on that, and then also through here, pertinent information that's required on sheets like the project number, the date, companies that are included in the project for that, the scale, obviously information for that. So, yeah, so we had that. Also, just wanted to point out for our design criteria, our owner supplied schedule, such as complete telephone systems. So we did have owner supplied equipment for that also. And the other equipment for that will be covered in a little bit more detail later down the road, and I'll actually be covering part of that myself through our load calculation. And we were also required to be in compliance with the latest version of our electrical codes. So NEC, NFPA, Minnesota Energy Code, and various Minnesota amendments. So we need to make sure to comply with those. So service for our building is 48277. It's a 3-phase 4-wire. Main service entrance equipment is a UL 1558 switchgear. And we did, like we said, we set it up for calculation for a 15% growth for our generator and switchgear. So, just briefly for emergency power in general, we did life safety for egress lighting, exit lighting for that, and 100% of the building electrical power. And then our switchgear will be a parallel equipment used for a closed transition for AZS and switchgear. So, and then I guess see here we get the power system for this. So for our power system, the way that we started was power coming in, and it's kind of hard to see here. This is our utility transformer here in our CD cabinet. Normal power you see is running back into our switchgear, and then from there, that power is then distributed to other transformers and other panels that are serving for that. These are our 2 UPSs and our PDUs that are both serving our data center for that. And then on this side, a little bit harder to see, this is our ATS right here, and the emergency power panel. That is fed directly from the generator for emergency power systems. These will be our bus duct for 208 and 480. 208 is fed from our secondary transformer right here. And the first transformer, which is our receptacle panel, which also runs the 208. And then we also had two mechanical panels, one for each floor, and then our lighting panel as well, which runs a 277 480. So, emergency power for this, upon shutdown, you're going to see the generators for close transition start up, so then the ATS items will switch over for us. The generator one right here, supplying power back to the ATS strictly for emergency power, for egress lighting and exit lighting. and then both of them supplying the switchgear to supply 100% of the electrical load for the entire building. And then these will be some of the equipment cut sheets that we use for these. So obviously with submittals and everything like that, these are very important parts of going through, for the equipment that we're using for projects itself. Also very important in knowing what type of fixture you're going to be using based off the information that you choose to use on each of the sheets. Kind of depends on, for some of these, it's hard to see, but they designate length for them. So you can use them in 4, 6 foot, 8 foot lengths for the size of the unit, depending on what you can use for that.
Derek, can I get you back just to mention the UPS and the PDUs? I think you forgot the other part on the riser. Yep.
Well, yeah, UPS and PDUs over here for the data center, as I was saying before.
Okay.
Yeah,
Oh, maybe I
so,
wasn't paying attention.
Yeah, for the battery banks and the transformer for that as well. So we're supplying for power, obviously for power, emergency power, and then power to make sure for critical power for our data centers for that. So.
Thank you.
And then this would be just one of the cut sheets that we use for our automatic transfer switch for that. So just giving us kind of, like I was saying, walking through which type of power we're going to be able to use for the ATS for those. One of the programs that we use for that is also Cummins Power Suite. So for that, we're able to put in our information to let us know what type of load you're going to be able to use for that. We worked in the system of building our system from the ground up before we went and sized our generator for the power. You can either work 2 different ways. For us, it was easier to do it this way because we didn't have experience right off the bat to know, this is what we're going to need because we have to work with anything in the future. So there's 2 different ways that you can be able to do that. Size the switchgear based off of what this type of plant is going to be based off of if you have that experience. We went backwards. So, but with that, the switchgear or the generator set, we're able to put in the information, and then Cummins can actually tell us what generator size we'll actually need for that. So this will be one of the panels that we use. This is a 100 to 400 milliamp panel, and then that right there is a parallel switchgear that goes through the system. And then now we'll break down into load calculations for this. For our load calculations, we use an Excel program and built-in macros for this, so that we can basically go ahead and use what the AMC had for calculations. Set that up in here so that we can plug in the numbers based off of how many receptacles we had, or how many light units we had, and then just let the computer go ahead and drop that information down in there for us. So receptacle panels, all the AC code for how many based off of 280 and 480 volt amps for that. This right here will be your switchgear. This is your receptacle panel, lighting panel, mechanical panel 1, mechanical panel 2, 4-way busway, 2-way busway, our UPSs, our PDUs, and our emergency panel. So for these, you can see for the receptacle panels, these are all going to be, well, hard to see right there, but the same for loads for UPS and our receptacle panels for those. And then also here too, we used for the data center, did calculations for that also, so that we could size based off of KVA for our UPS, to size that for our PDUs. And then this right here is our owner equipment list, and that'll be sized for both our mechanical panel 1 and mechanical panel 2. And sorry, this one was actually on a 2-way 480 busway. So for running through some of those, we were able to plug in the information for those based off of how many pieces of equipment that we had, KVA ratings, and then the demand factors for those also, so power factor and everything that we had for those. So plug in that information for it. Down the list from there, we used it for lighting calculation also, which is based kind of on the same format for it. We have the fixture labels for it. We use KVA, continuous load 1.25 calculation for that, and then let that calculation drop through. So you'll see here goes on the switchgear, KVA for the lighting panels, very similar all the way down for those. And then motor loads, which would actually be for the mechanical panels themselves. So you'll see these are broken off into 2 different sets, which equal the total amount that's going to be on the switchgear for that. So you'll have the total number of supplies, plus the load, and the voltage, and then the fan is also for that too, 1.632 for the three-phase system. And basically that all brings us down to the main set right here, which is going to be our total load, so it's KVA, total KVA at the top there. And then from there we're able to size down. So for our switchgear is a 4,000 amp switchgear that we use for that. Our lighting panel was a 175. Our receptacle panel was a 150. Both of our mechanical panels, we had a 300 amp mechanical panel for the first floor and 600 for the second floor. 480 busway was a 1,000 amp. 208 was a 600. And the UPS and our PDUs would be based off of KVA for those for sizing purposes. And then from that point on, we're able to go use that information to then size our wiring. So we can go from that sizing of three-phase wiring, which allowed us to do that also for our neutrals, our grounds. So, and then from there, move into the project schedule. And this basically allowed us to use Microsoft Project so that we can coordinate our schedule for the people involved in our project, the equipment that we need, the material that we need to use for the handling for that. And then we broke that down into subtasks as well. So we'll be able to help make sure that for timeline-wise, this will help keep us on track to know which pieces of the project we have completed, and moving forward, what our next critical tasks will be in the project, moving forward from there. That'll help us maintain that we're staying on project. You know, money issues and things like that, this is a huge thing for that. So, and that's primarily what I had for mine was overview, scope, and that. So, questions, concerns without the C. That's nice.
More emotional outburst.
Derek, can you explain how your generators and service and transferring power? Because you showed an ATS for the life safety.
Yeah.
You just sort of show the riser block. You explain, if possible, how you
For the generator power itself?
right, how you're transferring load from the utility to the genesis.
Yeah, sorry, yeah. Not a problem. Okay, so upon emergency power, so as soon as we're sensing power that is going to be launched from the utility side, our ATS is then going to transfer power from the utility side over to the generator side for that. Included with that for the UPS and the PDUs, we have our battery banks. So we're going to be able to hold power for the 15 minutes or whatever that it takes for the power on the generators to hold in line and take over power for our data center, backup power for those. In the meantime, our generators are going to start flowing power into emergency panels so that we have lighting and everything for that in the meantime. And then these will cycle up and take over, obviously, the power for the entire system at that point, but 100% of the power transfer for that. So the ATS, obviously, is the most important thing in there for the direct connection for switching between the emergency power to the generator power. And at that point, you're going to strip it off of emergency power for those that come in looking forward. You have to else.
In part, I think, and I know you talked about this, but the fact that those gensets feed into your switch gear and then the utility feeds into switch gear, so you're using breaker pairs.
Yes.
To switch load because those gensets will pick up 100% of the building, correct?
Yeah.
Okay. That's kind of what I was looking for. The operation of
Yeah. That's going to be for that.
And your parallel gear must be part of that.
Yes. Yeah. The parallel gear for the switch gear for that, and then that acts as the breaker for it as well. So, okay.
One more, Derek. We're going to put you on the spot, but what happened when the power comes back? Remember when we went to Cummins and how they did? You want to go over this?
Yeah. Power to come back. In that sort of system, what they're going to be seeing is when the power starts to come back at certain levels. I know with close transition, when we saw it for Cummins was that when it's reaching a certain level and negotiating kind of between that, when it gets to a certain level, they're going to be able to close the or open the switch again, so that we're switching power back from emergency power to the generator back over to the utility side. So, and then at that point, you'll be able to hear kind of everything wind down step by step. You know, the power load, once it reaches that point, and everything will start to go back to the utility side. And then, obviously, taking power off the emergency panels, and then switching power and mains and everything back over. Related to that point too, it's also a switch for the UPS to make sure that the batteries cover the critical information that you need for those data centers.
So we shift the load from the generators to the utilities.
Yeah,
That's when.
shift it back from generator back to utility. So.
We did put you on the spot.
No, that's okay. No, I'm for it, so.
Any other questions for Derek, guys? You're going to tell them where you are before?
Oh, okay. Well, yeah, and actually, I just wanted to throw out a thank you to also for all of the tours that we got to go on to, especially for Allianz. I really enjoyed being able to go out there, take a look at their data center that we had out there. It was a huge part of that, and being able to understand exactly what we were designing, knowing up close what exactly that does, and get a better understanding of that. So, but yeah, like Chad was saying, right now I'm at Parsons and doing my internship as a project engineer. So getting some good experience with that, and definitely learning a little more about the industry as far as that goes. But yeah, I mean, having you guys here is definitely a huge part of this program. So I definitely appreciate that, and the other things too. So thank you very much.
Thanks, Derek. I will be presenting next. I'm staffed with low voltage systems, the generator sizing, and I forgot to mention if they're going to be lightning protection. So, setting us off, this is just overviews of the low voltages on both floors. First, second over there, you can kind of see the cable trays that we have for low voltage systems with all the machinery. Obviously, I'll get more in depth into everything. This is just the telephone and data, the outlet that we chose, just mixed use. We had one in all the offices, anywhere that it was required to be, that we thought it would be necessary to have something like that. And the manufacturing floor for the fire alarm system, we had a beam smoke detector. So we had the receiver and the transmitter over there, and it would just send a signal across. And if smoke got up to that level, then the fire alarm would go off. We thought this was the best way to protect the roof with such a big space. This is the data center, and in here we have a pre-action fire alarm system, which I think was similar to the one in Allianz. So the only way that we would dump chemicals or liquids onto all this equipment was if we were 100% sure that there was a fire, and not just some clumsy maintenance guy knocking something on. So we just want to make sure that it wasn't an accident that the alarm went off here. These are just examples of the other smoke detectors that we had throughout into the duct smoke detectors when they were the security system, we just had door contacts on any door that led outside, and glass breaks near any of the windows in any of the offices or throughout the rest of the building. Here's a closer look at the cable trays. Pretty much just bringing everything to all the offices in the manufacturing floor. For the clock system, we just have a central clock throughout, and centrally located system in the electrical room, I believe, and then clocks throughout the building where we deem necessary. There was a paging system throughout, and we had a speaker come in and explain a lot to us, and different parameters for what you need, and decibel levels for what you need here, like in the manufacturing floor, it'd be a lot louder. You have to have a much better, more intrinsic system. So that's what these were, kind of like horns on the walls, and then in quieter spaces, just ceiling speakers. Here's some of the just cut piece of pictures of what we had. This is the pre-action fire alarm panel. That's the paging system over there. Kind of a better look at the horns that would be on the ceiling or wall. This is the beam smoke detector, one sending a signal across to the other, and then it's just a glass break. So for lightning protection, We had Thompson Lightning come in and speak with us. That was a very interesting discussion that we had with them. This is just a general picture of what we had throughout the building. We had to have spikes. See it a little better here. Split up correctly throughout, and then leading onto the exhaust fans, and pretty much from every corner. I think it was 50 feet. We'd have to have going into the ground so that the lightning would completely stay away from the building. It's kind of like a shell surrounding the building. These are detailed pictures of what the jobs look like. They're a foot tall. I believe 59 KC and a lightning conductor. Foot in length, 3/4 inch diameter. There's just a picture of it going up through the exhaust fan. And these are the grounding rods that we had that would come down from the lightning strut, come down through all the way, and just go under. And for the generator side, we had Derek touched on it. We had 2 gen running parallel, obviously going into the switchgear. And when we did tour the Cummins facility, we had them fully switch over from utility power to the generator, so that was pretty cool to see. You could definitely hear and almost feel the switches going on and off. That was very interesting. This is through Cummins Power Suite. We had to build all the wells and enter in all the information. So like here's the welding panel. We had one of the just air handling units. And then we entered in each step. So first, once we lost power and the generators picked up, the first would be emergency panel. And then we had the UPS's lighting panels, bus ducts, and then mechanical panels, just to make sure that we had what was necessary coming up first. Here's the project parameters. We really didn't change too much of the defaults. I think we just changed the altitude and then entered in the voltages and didn't have it quiet side. So then we just entered it all in and the program picked this generator for us. Having 2 in parallel, so we had obviously 2 of these. And that's everything. Any questions? Yep, overhead, and then coming in over the, I think in the ceiling over the open offices, and we had one that was underneath to the second floor. Yeah, we came in and showed us one. Either way, they seem kind of deadly if someone fell on top of one of those. Anything else? Thank you.
And Matt is available for hire. So just for the record here.
Alright, coming up next we have Karen Hopkinson. She'll be presenting the lighting layout, interior and exterior. And she will also touch on the visual software.
Last and least, my lighting designer.
Alright, and the last nor least, but I am a lighting designer, officially. And so we'll just get going right here. Building, so that we have some light in that space. And those are kind of just some visuals we get. We have a couple double heads and a bunch of single lights around the edges there. And the canopy lights are just mounted on the side at 9 feet. And the street lights are 30 feet up, just so you can also kind of get once again that visual from that. And they needed to have a minimum of 1 foot candle from the outside, and they must have a 4:1 ratio. We pretty much most freestanding within about 2 to 3 foot candles, so we're well within where they're required for us to be. So you can see your car, you can find out where you're going, and you don't have to worry about tripping on that pothole. And this, you can see we also have the controls. They're circled in red. They are photo cells, so they're not turning on and off randomly. And you don't have to use when you sit there and mess with people in the parking lot. They'll go on when it's dark, or if there's a storm, or something like that. That needed to have range of footprints depending on where it was, what they were doing in that room. Things like the waiting rooms, you only need 20-foot candles, but manufacturing, you needed to have 80. Second floor, sort of a similar thing. Break room's going to have 25-foot candles, but the research lab is going to have to have 80. You need to be able to see what you're doing at much better detail. So there's all the different lights used. The heavy-duty one in the corner, that one is for the hazardous waste. It needs to be a Class 1 Div 1 protected light. So we're not going to have any sorts of sparks happening or things flying up and getting into your lights and causing all sorts of unpleasant experiences for all those involved. And there's the different sets of lights for the things. There's some of them there's some overlay due to whether they're first or second floor. But of course you don't do, visual doesn't handle having both of them together, so you have to have them separate. Most of the lights are controlled by switching. The few of them do need some specific switches, like 3-way switches by stairs, because the NEC does require that at a certain level of stairs you do need to have 3-way switches at the top, and places like that. Going to 2 doors, and you can have 3 switches in case you're coming in the opposite door. The conference room did require a dimming switch, so you could adjust accordingly. So if you had a presentation, you could turn the lights down, or if you were looking to have brainstorming sessions, you could turn the lights up. The bathrooms did have a occupancy sensor, and those are just because you don't want to have people going in there and having it turn on and off. You just see the various sort of paneling layout and schedule for that. Let's go back and readjust, change things that were LEDs to LEDs, and then we came in at 2% better than code. The outdoors we had a much better luck. That came in at 55%, and that came in the first time around as opposed to the third or fourth time.
Are there any questions before we proceed?
You mentioned your sources and the lamps. I missed out. Was there a fair amount of LED technology used?
Yes, there was. That particularly ones in my energy code product. Not a very good one. So they did switch to a lot of LEDs. The outdoor lights are all LEDs. It's all full to encourage to have better
What was the fixture source you used in the manufacturing space?
You asking like did you use a lot of lights?
Not manufacturing, but did you use the LEDs in the manufacturing space? What type of fixture was it that you used in that storage space?
Oh, that one had a for manufacturing space. That one was a three lamps, 4-inch strip like that had LEDs in it. Any other questions?
So, I think you had emergency lighting for the whole building with light, so did you have to have a separate
went into a different panel entirely. That was on the emergency panel versus the lighting panel, so those would come on immediately when the generators kicked in, and that was a little later, and coming a little bit later, and it wasn't pregnancy for that. That's right, that first part of the
I'm curious what that is, the emergency lighting that has, so it can block.
I don't know what that was. I know it's required to be about minimum of 1.5 amps per space. I don't know what ours was. The lighting did not transfer very close visual, but I couldn't get it to tell me how much wattage it would have, how much more amps it would have per space. Any other questions?
You said you're a lighting designer, so you just have a program, or were you just designing lighting?
I have a theatrical lighting experience. So I actually do design lights for shows and various things. So it's actually what I do. Any other questions?
Thank you, Karen.
Ready? Oh my God. Oh my God. Just don't.
And also Karen is available for hire, so if anybody want to hire too. Next is
Thank you, Karen. Before I introduce Adam real quick, I just want to say thanks again for coming out. Another great turnout. It's exciting to see all these people come out. Next is Adam is presenting power layout, scheduling, mechanical and owner equipment schedules, UPS and PTW sizing, and power tools.
it's right there. Yeah. What 2 steps here? Yeah, it's right.
Morning, everybody. Morning. Power. Everybody loves power. All right, so quick overview here. Power first and second floor. This is the circuiting layout. Schedule first and second floor. Some equipment cut sheets and mechanical and owner layout circuiting. Mechanical and owner equipment schedules, ATS sizing and cut sheets, UPS and PTW system sizing and cut sheets, and the power tools for window short circuit analysis and overcurrent protection coordination. All right, just a quick, this is just first floor. I didn't, I'll just show you, I'll just tell you right now, the UPS and PTUs, 2 UPSs right here, and PTUs will be right here and here. What Derek pretty much talked about this. We basically we took 40 racks in here, and we took 5,000 K per rack, and multiplied that by 1.25 continuous load, and we got our KVA. And then again with the UPSs, if they're on for 15 minutes, and then the generator will kick in, and then those will run. And UPSs are battery powered. This is our generator room. Auto transfer switch up here. Basic receptacles. We only did 6 receptacles to a circuit. Just kept it to 6. Our receptacle panels, lighting panels, emergency panels, and mechanical 1 panel. Our mechanical 2 panel is going to be on the 2nd floor. I'll show you that in a little bit here. 4,000 amp switchgear with our, just a picture of our 480 bus duct. And then transformers. One of the transformers is for the 208 bus duct, and I believe the second transformer is for our mechanical panel 1.
I believe.
Receptacle panel.
Receptacle, yeah.
Yep.
Electrical and mechanical room, we have our boiler, just a 120 volt boiler, with our, this is the, I believe the boiler feed pump. That is 480 with a motor starter. The domestic booster pump with a motor starter, and these are glycol chilled water pumps, and then just regular chill pumps on this side, with a chiller and a disconnect. Our data center, like I said before, our 2 PTUs with, and then in there we have our cooling units, 2 cooling units for the data center. And then we decided to set it up with special receptacles on each side. And again, 40 racks. And then our UPS would be actually down here in the picture I showed you before. Manufacturing floor. 480 bus duct and 208. Just a few, really blurry, a few older equipment stuff I'll point out here. We have a tube mill. Throughout, and there's 12 of those machines, and that'd be on the 208 bus duct. And then we have end flare, 208 extruder. Extruders on 480. Chemical pump, chemical cleaner. All these under equipments on our bus duct. Second floor. Here's the second floor layout. I'll just tell break room. There is many machines we decided to do separate receptacle for each running machine. Mechanical room. We have air handling units. Me and Jack talked about this morning. I didn't put in the, we have a family for VFDs, but I didn't put that in. These are the VFDs, but it's motor starter. Jack explained to me the special motor starters are a special type of.
VFD is part of a motor starter.
So we have six air handling units up here. With our, like I said, our mechanical 2-panel in that room. Research lab. We have plug strips going across on these tables, along with our environmental chamber with a disconnect connected to it. Penthouse on the roof. We have 5 exhaust fans. The other one up there with a cooling tower. Some of the screen stuff you've seen some of the lightning. And then these exhaust fans are connected. Each one has a TFCI receptacle connected to it or for it. Mechanical 1 and mechanical 2 panel schedules. The mechanical 1 panel was a 300 amp, and the mechanical 2 panel was a 600 amp. The receptacle panel, 208, that was our only system. I believe that shed, the receptacle panel was the only 208 system in the whole building. Everything else was 480.
Switchgear, 4,000 amp, like I said. Cut sheets, basic our auto transfer switch, along with our PTW. Switchgear here, and our UPS system here. Power tools for window. Some, and Jared touched on this a little bit earlier. Generators. So we have two generators from a breaker, and then this goes down to our ATS that feeds our emergency panel, and then that goes to another breaker in here, which feeds. This is our 4,000 amp switchgear connected to the lighting panel, mechanical 1 and 2, plus step 480, our receptacle panel with a transformer connected to it. 208 with the transformer, UPS system, environmental chamber, and chiller. Oh, and we also connected from the mechanical panel. We connected one of the air handling units to the mechanical panel for this. I'll show you breaker information. This is the breaker from the 4,000 amp switchgear, and a cable, the 2-way bus cable, just basic copper magnetic communication. We're using 3-wire plus ground, 350 kcm, and they're parallel to. Our flash labels, basically going through, explains what can be worked on properly. This would be our coming from the utility. We don't have overcurrent protection coming straight from the utility, so that has to be turned off in order to work on it safely. But lighting panel, mechanical 1 panel, mechanical 2 panel, environmental chamber 2, bus up 280, 480 bus up, and environmental chamber 1, showing all the PPE levels. Short circuit analysis on just the whole one-line diagram. Just showing, like for instance, 480 bus up on the 3-phase, it will fault current at 59,000 carry, 36 amps, and single phase 42,057 amps. Coordination curve, air handling unit, fully coordinated here, showing the main breaker, and then mechanical panel 2 curve along with the air handling unit, circuit breaker, and the actual unit itself. Load report for that air handling unit. I'm giving all the Cutler hammer we use 100 to 400 amp, 65 K. Chiller coordination showed again the main breaker along with the chiller, and then the chiller itself fully coordinated. Another load report for that chiller. Used that breaker was a Magnum DS RMS 520. 200 to 800 amp plugs. Any questions? I'd just like to say that, yeah, actually, it's really nice. I work for Mech Cooling. I started October 2nd, and it was nice just having them come every week and just giving us all these tours. It's really cool. Is there any questions you guys like to ask or any concerns? Yeah. Yeah, this room actually goes from this room, it goes to this room. This is our another mechanical / electrical room. That's what it's
I'm just making sure that we have double doors for access for you, for the service and everything like that, so.
oh yeah.
We doubled the clearance. We took the exception. The other one. Egress door.
Get out without
Any other questions or concerns?
Go back to your advisor.
On PTW?
Yeah. Okay. So, we talked earlier that the generators basically support the total load that the utility does. So can you explain which breakers are involved in that operation?
Yeah. Well, so, okay, so two generators. Obviously, we have our breaker up here supporting the ATS, and then we didn't have a supporting breaker. Sorry, yeah, you said.
Well, that's the emergency side, so that's the life safety code required side. I'm talking about how we are able to get that rest of that load on the two generators. And you talked about the fact that there's parallel gear involved. Which breakers are involved in getting that total building load onto those two generators? I'm just
Adam, I'm going to give you a lifeline. You see these? Do you see these circuit breakers right here? Yep.
These two circuit breakers, this would be supporting elements in this whole bus guy.
Yes, the switchgear.
Switchgear, and yeah, that would obviously
So the generators, Adam, these two generators will dump the power through these two circuit breakers when everything is up and running. So it's hard to answer a question from your boss here.
all right, you did.
Emotional concerns. All right.
Thank you, Adam. Great job. Thank you. You did a great job, Adam.
Okay, well, gentlemen, this is all we have planned. We do have this room for 1 more hour, so we would like to invite you to hang out here, visit with the students, visit with each other. There's the project start here. If you guys would like to look at the complete documentation of the project from A to Z, please look at this. I just want to say a few things, guys. Just imagine when I was in college, and those kids, before they came to us, they've never ever heard of a switchgear, let alone a panel, a PTW, a UPS. So you take them from people who've never heard about a panel, very knows Ohm's law, into dealing with paramedic switchgear. So just to give you an idea, in 2 years. So that's, that's a big step for all of you guys. You did a great job. I think you are trainable for an entry level, and we have 2 more people to go guys we are hiring. Karen is sitting right there, and where's Matt? Matt is sitting here, so hang around here. We have a lot of cookies, so why don't you guys go visit, and that's all I have for you. Thank you. we just show up here for the projects and guidelines or something?
Well, just a comment, sort of add support here, and what you're saying down through. When I interviewed at Ellerby way back when, 1971, Ellerby, way back when, we had an inking drawing. So the exercise in class was to do an inking drawing of a unit substation. I had no idea what a unit substation was. This was after 2 years of technical school. But the guys at Ellerby were so impressed that the guy I interviewed with pulled people in and showed them what I was able to do. And I felt kind of sheepish because I was afraid they were going to ask me to explain it. I had no idea what a beautiful inking drawing of a unit substation. But I think it helped me get me hired. But yeah, you still have a lot to learn once you leave the 2 years here. So. And it will help.
Yeah, thank you guys. Make sure you leave me and please hang around with me. But I would like you to leave that sheet for a movement. That makes sure you have something like that. And please make sure you just sign the sheet that you'd like to sign for yeah, I've got that's not there.
Hey, how you doing?
Others coming back.